Hello, and welcome to my talk on supporting quality assurance with automated process-centric quality constraint checking. This research is done in the context of quality assurance for safety-critical systems. These systems are typically subject to regulations, standards, guidelines for traceability, such as the FDA principles in the medical domain, or DO 178C for airborne systems, or the ED 109A standard for air traffic management systems. This is the example you see in this picture of a remote tower with voice communication between air traffic controllers and pilots. The problem here is that while the regulations prescribe traceability requirements, they don't prescribe the engineering process, so companies have the challenge when and how to check these constraints during the process. As a bit more details on this example, we have this following traceability information model here on the left that describes high-level requirements, low-level requirements, that traces to design specifications, subsystems, function units, and test cases. On the right-hand side here, you have an example process that describes how high-level requirements and high-level specifications are reviewed, how the requirements to subsystem coverage review is done. Then this should be done refined into low-level requirements, the specification updated, and then again some more reviews done. And the question is, when can these constraints that these checks are there and what additional quality constraint checks be done at which step, and also providing feedback whether about to refine the requirements, whether this review has been already completed or how far has this review gone before I can start early, so I can assess as a developer the risk of starting early or perhaps skipping a step. The general problem is that developers and quality assurance engineers are typically overwhelmed by the complexity and extent of the regulations. Typically, a developer might be involved in multiple projects at the same time. Each of these projects might have different standards, and a lot of these checks are error-prone, tedious, and mind-numbing because they need to involve navigation across different tools. So one of our quality engineers at the contact of our industry relation partner Frequentis told us that 30% of his time is spent on checking and coordinating these issues with the developers to fix these unfulfilled constraints. And there's a lot of constraints because we checked, and for 109 process examples, for a few constraints only, there were 14,000 connected artifacts and over 27,000 change events that would trigger such checking. So quality assurance typically checks this with a delay, and then feedback goes to developers often when they already have moved on to another task, disrupting them and requiring them to think how did they implement this and which traces should be correct and what might be the solution to any unfulfilled constraints. Our approach to this problem is the passive process execution environment, which observes developers in their natural environment of their tools such as Jira or Jama, and we observe changes in these tools to check which process has been progressing, having constraints as first-class citizens, and therefore being able to detect where are deviations and where has work stopped prematurely. To this end, we take the same informal process definition already typically available within companies and produce something that can be automatically executed and that is mapped to tool connectors. Then eventually, through a dashboard, stakeholders such as quality assurance engineers, the developer themselves, also team leads, are able to inspect whether any violations have occurred. The example prototype here is a web interface that shows for each process what are the steps and the constraints, whether they are fulfilled or not. And please follow this link to a YouTube video where you can see this prototype in more action. It's also available as a exit demo paper this year. We evaluated this work based on two datasets, one from Chronology, which is an open source system for unmanned aerial vehicles, which uses primarily Jira for tracking of requirements, hazards, bugs, features, and their links between. And here we take each of these Jira issues in the different forms as a process instance, and we get between 36 and almost 250 instances of these kind of small processes. On the other hand, we took Frequentis, our industry evaluation partner and one of the air traffic control systems where they use Jira for work package and sub-work package tracking, and then uses JAMA for high-level and low-level requirements, design definition, and test case management. And here we took one example process excerpt where 4 steps had 8 constraints, and we took 109 process instances. Example constraints in these 2 case studies were, for example, for chronology, is the issue traces to one or more design definition, or is an issue mitigated by a requirement or refined by a hazard, each with the correct trace type. For frequentis, we had things like no traced low-level requirement has a trace to another subwork package with a status other than closed, or all traced low-level requirements have linked to at least one test case matching the requirements verification method. So you see, these are not trivial constraints, but these can be nicely automated. What we did then is taking the change history of all of these artifacts and replay the change one by one and always evaluate the process and constraints after that change. And then we logged whether there was a progress to a next step while there were still quality constraints violated from a previous step. So what we looked at were which processes were always okay, which were okay at the end but had violations in between, and which were finished, which processes but marked as finished but not complete in terms of quality constraints. We also looked at the incomplete process instances, and here also we're looking at which ones had progress with or without constraint violations. And while we, for an open source system such as Chronology, which is not mandated to provide these constraints, there are more violations. We've also found a few for our industry evaluation partner and had a look into what was the case. And what we found is that there are constraint corner cases where certain constraints didn't apply, or forgotten traces where they were provided in Jira comments but then not actually provided explicitly in JAMA, or for even the incomplete processes that were actually supposed to be complete. There it was some indication in Jira which were used for tracking process progress. These kind of checkboxes have been missing. So here we see some potential in supporting the engineers in completing the process and quality constraints as they were supposed to, without too much feedback from the quality assurance engineer. So what is ongoing and future investigations? On the one hand, we want to understand in the field when using the prototype there, which is currently ongoing, how are quality engineers benefiting? So are they really saving on time? But also, how are developers benefiting from this approach? Is it a blessing that they have to do less, or is it a curse that they are now more rigorously checked? And another aspect is in the spirit of Leo J. Osterweiler, processes are software too, where we want to understand how these processes can be tested, defined, reused, updated, and so on, just as regular software. And if you're interested in more sophisticated, more exciting research ideas for this, please also have a look at the NEAR paper this year on inconsistency tolerating guidance for software engineering processes, which is also available as a preprint under that link here. And with that, I would like to thank you for your attention, and I'm very happy to answer any questions that you send to me via email or Twitter or otherwise. Thank you.
Hello, everybody. Thanks for joining us today. I am Silvia Brown from Universitat Politécnica de Valencia in Spain, and it's my pleasure to welcome you to this session on quality assurance. So let us go directly to the Q&A question for the first talk. I hope you enjoyed the Christopher's presentation, and he is here today to answer your questions. Let's see. Yeah, we got one question in the chat from James, and he's asking, do you think the use of automated process enforcement systems should be required by regulations?
Thanks for the question. Well, I think as the whole purpose of this approach is to kind of guide in the background that doesn't enforce something, I would feel that it should be just used as a meaningful add-on, but not really as an enforcement, because you might still have to also deviate here. It just helps supporting your developers, and any kind of things that are forced to use kind of gives them perhaps a reason to, again, not use a particular system. So I would say I would not recommend enforcing any such system, because people might not want to use it, might not be very applicable in any context, just as a supporting tool, I would say.
Thank you. As there is no other questions in the chat, I'm going to ask one. I have a question about the passively executable process, specifications and constraints. If I understood correctly, these are manually derived, and it seems that you, the authors, created these specifications, constraints, and I would like to know what is the effort associated to the derivation of these specifications and constraints, as well as the creation of the connectors to these tools.
Okay, yes, so there's three different aspects I would say. So writing the connectors is typically something that is done by an IT department, or the tool provisioning, the process supporting inside a company. So you typically would write it perhaps once. If you use Jira, you have the connector. If you use another tool, such as we have now a new company trying out this tool, we write a new connector, and then this is done once, and then you have the information available there. So the actual developers or quality assurance engineers would not be the people that would have to do this. But writing the rules themselves, there's a little bit of upfront effort in getting to know how to write this, but a lot of that is at the moment, unfortunately, still boilerplate code to write. So typically copy pasting from previous rules and adapting the logic. And there, I mean, ideally, we would like to have something more end-user friendly, such as Scratch or Blockly-based interface that can then be converted into these rules. We did a few first experiments, or let's say trials into that direction. It's not quite that easy, because we also realized that tools are used very differently with different companies. So one company might use dedicated fields for every single input. Other companies might then use the description field and use HTML to mark up the different parts of that information. And there it becomes a lot harder to kind of use a general applicable approach, and you might need to go into a lower level language, like in this case, lower level like Java, to express your logic. But I would say it's still a programming effort, and it depends in the company whether a programmer also uses these tools. So far, the experience we had with the one company trying out this, developers were using the tools, were also developing these rules then themselves after some initial guidance. So that definitely is a valid point for adopting the system, yes.
Okay, it makes sense. But do you have any plans to provide like a guideline on how to properly define these specifications, and also mapping them to the artifacts, and maybe involve QA engineers to test this, to use these guidelines? Do you have any plans in this direction?
So what we focus on is it's definitely on how to develop these constraints in terms of, okay, you need to be able to test them. You're not going to write a rule and then deploy it to a live system, and then perhaps this rule does not work because you might have not used perhaps a different property that is actually in the system used. Or so there's definitely, we try to have a small development environment, basically where you can quickly test those rules, whether there perhaps are any syntax errors there that are not detected, or that you can also try with old data. So last year's ICSI paper, we have there a demo paper for replaying artifacts, so you can see how artifacts change over time, and this then can feed into testing a process that you see, okay, for this artifact changes, this is how the process would evolve, and therefore would these constraints really be triggered or not. I hope this answers the question.
Yeah, yes, sure, thank you. We got another question from James on the chat, and he's asking about if you encountered processes for which a more complex logic system is needed, or just a system with capabilities or it's sufficient?
So from what the companies try to check is typically what so far humans check. So it's typically, as you gave in examples of these thresholds, whether there's certain properties set, this is the very basis. The next level, as already what we've seen, is navigating across artifacts. So from a Jira issue, I navigate to a JAMA issue, or from a Jira issue, navigate through its child tasks, and then again check certain properties there. The thing also is that companies they haven't started thinking about what would be more complex ones, because these complex ones so far now need to be done manually, and already now the current ones are take a lot of time to check. So anything more complex would need so much time that they haven't really defined any kind of these constraints yet. But I would imagine that once they kind of get used to such a tool, that more complex logic might be needed, where you would be more inclined to kind of need more navigation. And there, I guess, once it comes to that space, there's definitely the opportunity to include more complex logic. But at the moment, we haven't seen just the need, and the examples really say that is something useful.
Thank you. I have another question, as we don't have any other on the chat. And my question is related to the automated checks. These checks reduce the effort for performing manual reviews by ensuring that the review are syntactically correct. So I was wondering how syntactic correctness are ensured in your approach, and if you have performed a validation to ensure that the traces under review regarding the artifacts adhere to the underlying process.
I'm not quite sure I absolutely understood correctly your question. So on the one hand, we have the traces could be, for example, from like a low-level requirement to a high-level requirement. So we can check whether we can define rules whether this is this trace is there. We can also check whether the property from the current artifact and the property from the traced artifact fulfill some condition. Whether this trace really should belong to that other artifact, this is something that needs additional work, additional tools. I think also my co-author Jane Cleland Huang, she also worked on this kind of checking, are these traces, might they be correct? So checking whether the actual link makes sense or not. So that this is also the reason, and in our case with our case study industry partner, they have dedicated human-centric steps in the process where they do a review whether the traces are indeed correct. And these quality checks that we then address in the paper are kind of preliminary checks, so that if you come to this review, you have at least the assurance that the traces you've got to have there linked to the correct item, they fulfill the correct properties. But it would be also possible eventually to build connectors that automatically execute such checks. That would say for high likelihood that trace link is not correct because the words from this requirement don't quite match the word from that requirement. So I mean, there's options to bring in this kind of work.
Okay, thank you very much